Hi, I'm Aliso Sanger from the Aspen Global Change Institute, and I'm here today to give you a quick introduction to the Roaring Fork Observation Network, or IRON, which is our long-term research network here in the Roaring Fork Valley. Before I begin, I wanted to say a few brief words about AGCI itself. We are a nonprofit committed to advancing global change science and solutions. And throughout that really broad scope of work, we have kind of three unifying themes within the work we do. One is that we try really hard to be interdisciplinary in approach. The next is that we really try to have some sort of partnership or collaborative approach to the work we do. These are really gnarly problems we're working on. We feel like we need a really great diversity of minds to help us address problems like that. And then finally, we try to make sure that the work we're doing fills a need or a gap that isn't already being met in either the scientific understanding of or even the data itself for understanding global change. So the project I'm here to talk to you guys about today actually really exemplifies all those three qualities that I mentioned. So the IRON, our long-term observation network, is something that is interdisciplinary in nature. We're looking at ecology, we're looking at hydrology, we're looking at the interplay between the atmosphere and the soil and the streams. So we have a pretty broad approach to this work. Next, it is collaborative. This project would not have been possible without our partners. The vast majority of our funding for this project so far has actually come from local funders. And so it's really important to us as we do this work that we're constantly thinking about how is this data going to be applicable to our partners. And then finally, in terms of a data gap, as I probably don't need to say to this group, soil moisture is something that we don't have a whole lot of in situ data on. And so that's where we really saw a need in better understanding the water cycle and the interplay between what happens when our temperatures warm, what will that mean for our streams and rivers. So this station today that I'm going to show you is Sky Mountain. It's our oldest station. This network started in 2012. Today, the network has grown to be 10 stations wide, and it runs from the top of Independence Pass at 12,080 feet, all the way down to near Glenwood Springs, which has the confluence of the Colorado River, at 6,200 feet in elevation. And speaking of the Colorado River, I want to orient you about this basin. We are headwaters for the Colorado River, and a pretty critical one. Geographically, we make up 0.6% of the land area of the Colorado River. But in terms of water we contribute, it's the full 6% of the flows of the Colorado River annually on average. And that doesn't even account for the water that gets pumped up and over the Continental Divide to the Front Range to help water supplies there. So even though we're a pretty small basin, we do have an outsized impact. And our hope is that this project will be both locally and regionally important, something where we really can kind of get dual use out of this data, maybe even triple use for other folks who are researching climate impacts on mountain systems. So what are we studying? What are we collecting to get that information? To kind of orient you, this station is a typical instrumentation suite for what you would see at one of our stations. Starting from the top, we have a tipping bucket rain gauge. Just below that is a solar panel to give us power for the whole station. Next to that, you see the radiation shield that protects our temperature and relative humidity sensor. And then below that is our logger box. This is a cellular capable logger box. So it's collecting data every 20 minutes, sending it out about every 4 hours, which is pretty great. And this is the equipment we use for most of our stations, or the onset logger boxes. For stations that don't have cellular capability, where we've had to go with a satellite box, we have had some other companies' equipment out there. Then under the ground at 2, 8, and 20-inch depths, we have soil moisture sensors. So that's 5, 20, and 50 centimeters. And then 8 inches down, we have a soil temperature probe. And for soil moisture at this site, we are using the Decagon dielectric probes. All of the sites use the Decagon dielectric smart sensors except for our newest site at Castle Creek, which is a mix of Campbell and Stevens equipment. And so the soil moisture sensors at that one are Stevens hydroprobes. So what are we hoping to do with this data once we collect it? Is always a good question to ask. We have both long-term and near-term goals for the network. For the long-term, oh, there's a hummingbird, how exciting. We're looking for climate changes over time. So we're hoping that we will eventually have a multi-decadal record where we can really start to see, as we're seeing warming temperatures, which is something that's already happening up here, what does that mean for soil moisture and for water supply and for the plants that are relying on that? In the near term, we have some questions we're able to answer and talk to about with our local funders. And that's actually really important to us because if we're asking for funding for maintaining these stations for the long term, it's helpful for them to be able to go back to whoever they're accountable to and say, here's what we've learned so far. And so in terms of that, we're looking a lot at kind of just system dynamics or interplay between different variables. So another example of the type of data that we found useful in the near term is just year-to-year comparisons. So we just had a very large rain event here a couple weeks ago, but prior to that, this was an extremely dry summer in the Roaring Fork Valley. Throughout April and May, we had almost no rain, and there was a huge concern about fire and about water supplies. And so I had partners asking me, how does this year compare to 2018, which was another year when we had a really large fire up here, and it was a year that was on everyone's mind. And so what I could tell them was, these are the types of things that we can look at that are similar or different from 2018. So here, this graph right here is one that I actually used directly with partners, where I could show them things like date of snowmelt, which ties into, of course, date of soil saturation and how early we see soil drying in the spring and summer. I could also point out things aside from rainfall, such as the importance of drought memory from year to year. So going into 2018 versus going into this year, what was the soil moisture level for fall? So what was our start point for taking up water in the spring when the snow melted? And that's something that was a message that really got home to folks this year, because our streams and rivers were only at about 40 to 60% of average flows this summer, whereas our snowpack had been around 80%. And so there was this question about, where does that gap come from? And so this was a really nice visual way where they could easily see the soil moisture component of that question. So that's where we're at right now. Those are the types of things we're currently looking at. And looking forward, we have big ambitions for this network. So this station here is officially turning 10 years old. And as we look forward to the next 10 years of this network, we want to start thinking about what should that look like in a really strategic way. So as we move forward with this project, there are a couple challenges that I'm sure will be familiar to a lot of you. One of them is obviously funding, but the other major one is that we're a fairly small organization carrying out a research network. And so this is what makes partnerships really critical to us, whether it's talking about data use and application, or whether we're trying to work on data validation and making sure we're using best practices. We really want to make sure we're working within a community so that we can leverage those different opportunities that different places have. So I'll be putting my contact information at the end of this presentation. Definitely please reach out to me if you're interested in working with us, or if you know anything about best practices for fieldwork and data validation for soil moisture. So the closing thought that I always have out in the field is that behind the data collection and all the other goals we have for this project is this overarching goal that through better understanding these ecosystems that sustain us, these water systems that we rely on, that we can hopefully work with our partners and our stakeholders and the public to make sure that we are able to manage these systems in a way that is sustainable and that is informed. Thank you for your time.